Hello, and welcome to 5 Minute Math. Today we are looking at activities that teachers can use to help reinforce the concepts of Algebra 1 Standard A.9C, writing exponential functions. This is a blog post on my website, 5minutemath.net. I will put the link to this blog post in the video description. So as we scroll down this blog post here, you see we're going to have three different teaching videos. These are my TEKS videos, and they just explain different aspects of this standard. So writing exponential functions from tables, writing exponential functions from real-world situations, and writing exponential functions from graphs. So in case you or possibly students might need to brush up on this standard, those are some videos explaining what it's talking about, how it works. The reason I'm doing this is because of our most recent STAR test. The 2023 STAR test, we had some pretty poor performance on this standard. It was tested twice. The first time it was number 14, and here's the problem itself. Only 37% got it correct. The really difficult part was the rate was not given to students as simply a percent or a decimal or anything like that. They had to represent the rate. Take a look here. They had to represent the rate as a fraction. So that probably threw some kids off. This is a video explaining how to solve that problem. And then you see it was also tested again, number 36. We did a little bit better, and you notice the rate was given to us as a percent, and so our students were able to capture that, grab the correct answer, at least 50% of them. So that's better than 37. And then this is a video once again showing how to solve that problem. Now, the theory behind these activities, these are not just extra worksheets. We want to give kids multiple at-bats at these problems, and we want them all to be active and playful, because when students are active and engaged, they have meaningful work. When there's social um, constructs within the activity, and it's just joyful and it's iterative, they could do it again and again. That's fun. There's nothing that says that math can't be fun and learning algebra can't be fun. And when kids are more active, when they're more playful, they're locked in and they're going to learn a lot more. So just want to know what the design principles are behind these strategies. So let's look at our first one. The video that I'm making right now will go right here underneath this. Here's a walkthrough of all the activities on this blog post. So here's our first activity, exponential growth and decay scavenger hunt. Now this one, along with another one, actually work with both A.9C and A.9D. A.9D is graphing exponential functions and identifying key features. But one of the difficult things about exponential functions is trying to grab them from real-world contexts. And so the idea behind this, and I've linked a digital recording sheet, I'm going to switch over to that. Kids are simply going to get with a partner. They're going to find an example of an article or a news story, not a math practice site. You'll find that if you just Google exponential growth and decay, you get all kinds of math practice sites that explains a real world example of exponential growth, or you've got exponential decay. And, we want them to, this is a Google Doc, so you can copy it, edit it for your students, let them edit it. You want them to copy and paste the URL, right? Describe the real world situation in which that exponential function was applied, and then what actually is that equation. And then if students struggle, right down here, we've got some examples that they can search for. These could be search terms, right? Population growth, compound interest, epidemic spread, radioactive decay, drug concentration in the body, cooling of a hot object. Those all use exponential growth or decay. So it's pretty simple. You want them to use the digital recording sheet, search for a news article or news story, and then copy the URL, type the example, explain the real world context, and then write out the exponential function. And that's it, because we want them to see how exponential functions apply in the real world. It's not that difficult when you're given the exponential function, but when you're given a story problem and you have to recognize that it's an exponential rather than a quadratic or a linear function, that's where the challenge comes. So here's some variations. Um, if you want, you could just give them, you know, hey, go find exponential growth and decay. If you think they're going to struggle, you can provide those real world examples that I provided on page 2. But if you think your kids are up for a challenge, exclude that for to begin with. Use that as a scaffold if you need some additional support. In addition to writing out the equation, go ahead and have the students write out the A, the initial amount, and B, the scale factor, right? So have them go ahead and name all the components of that exponential function. You can also have them create a table with the equation, then plot out how the function changes with various time periods, like 1, 2, 3 years, or 1, 2, 3 weeks, 1, 2, 3 hours, whatever time happens to be, and then they can graph it. So if they can find it in the real world, they can understand how the exponential functions work in the real world. So that's one activity. So our next activity is called exponential card sort. Our learning objective here is we simply want to classify the problems into two different groups, exponential growth or exponential decay. And that's going to make a difference when they're trying to calculate the scale factor and it's given to them as a decimal or a percent, right? Because they're going to have to either add or subtract that from 1. So what we're wanting to do is we're wanting to provide them a set of cards. And so here is our set of cards right here. And you'll see we got 9 here, got 5 here, so for a total of 14. And it's not necessarily a memory match. All we're doing is we're taking this and we're reading the problem and we are trying to understand, is it exponential growth or is it exponential decay? And how do you know? So some of them are going to be obvious. This is exponential growth because it says it grows by 5% annually. This one is exponential growth, but it doesn't say it. It says it doubles, right? Now, we've got an example down here. It says decay, so that's pretty simple. But what about this one? A card depreciates in value. So we're wanting kids to find these keywords that help them understand, is it exponential growth or is it exponential decay? And the learning is in the conversation. How do they know? We're asking them to discuss how they know which cards went into each category, and then they can create an anchor chart, or you as a class can create an anchor chart of which keywords that were found to explicitly name growth and decay other than obviously growth and decay. So after they sort the cards, you can have them write an equation for each of the cards if you want. You can ask them to solve one card from each category because if you were reading this, you're going to notice, take a look at here. The social media influencer currently has 10,000 followers. If their followers are increasing by 20% each month, that's pretty high. That'd be great. Write an exponential function to model the number of followers after T months, and then determine the number of followers after 5 months. So you can write the function here, and if you want, you can actually plug in that 5 for your X, and you can actually figure out how many followers they would have after 5 months. So not only sorting it, they can actually do a little work, writing the equation and then solving it. And then you can allow them to use those as examples, create their own problems, swap them with another group, and then sort. All right, our third activity is exponential matching. So this is basically a memory match. It's going to be some more problem situations, but it's going to be a lot less robust than you would get in this card sorting, right? But you are going to see here that we've got this exponential matching, and what we have are, we've got 12 up here, and then we got 12 down here, and I did it for you so that the same position has the word problem and the function right here. So a bacteria doubles every hour, so it's y equals 2 to the x power. Okay, and so the value of a card depreciates by 10%, right? So then we got y equals 0.9x. You notice we're not necessarily working with an initial amount. We're just trying to find a function. This is the y, the a is just not there, it's just b, the scale factor to the x. But we're really trying to short and simple do a memory match because if you get too much, it's going to be kind of hard to keep these in mind. So you play like you would memory match, right? You flip two cards up. If they match, keep them. If not, it's the other person's term. And you're just trying to match the verbal description and the exponential function. And these are simplified because we took out the initial amount. And then play continues until all cards have been matched. Pretty simple here. They can play alone for individual review. You can, if you want to make it separate, instead of mixing all the cards together, have a pile of face down cards that are the functions, a pile of face down cards that are verbal descriptions, and they pull one from each pile, just so they don't pull two verbal descriptions on a turn. And if you want to use those two different groups, another variation here is have them first pick a verbal description. And then before they pick up a face down card from the function group, they need to say or write the exponential function they're looking for. That's an added twist. And then after the play is ended, have the students take their matches, find the value of the problem situation after 5 time units, and then you'd have to supply some type of initial amount. Exponential story problems is our next one. This is another one that kind of lives in both A.9C and A.9D. Here are some real world examples, right, of context that you could use for exponential growth, exponential decay. You saw those also on this exponential growth and decay scavenger hunt. What we're wanting the students to do here is we are wanting them to take one of these contexts. They generate values for the initial amount, the growth and decay factor, the time unit, write a story problem. So that's what we're going to see here. They first label, okay, what are the time units? What's the scale factor? What is the initial amount? And then type the story problem underneath, or you can have them handwrite if you want to print that out. And then they swap with their partner and, they solve each other's problems. Now, you might think that's easy, but even if I give you the context, how do you frame the language? The more we can get these kids to create problems, the more experience they're going to have when they're trying to identify exponential growth and decay within verbal descriptions, because creating it just requires a lot of different math muscles than simply reading it, analyzing it, and then identifying what type of function it is. So we want them to create these story problems. They can swap, right? If you want, you can give them limitations for the values, right? You want to make a growth factor with a shallow curve. You want a y-intercept initial, value, obviously, that's greater than 10. If you want, you can add a few of those little wrinkles in there. You can have students swap with a partner, not only write an equation, but also sketch a graph, and then double check that graph with a graphing calculator. You can have them provide some, feedback. This is editing, right? So they're looking for clarity of the problem, proper convention, syntax, grammar. Instead of matching an equation from the story problem, have students give the equation and then omit the other another component, right? So the initial amount, the growth factor, and instead of having the story problem be written so that the question asks what is an exponential function that represents this situation, have them give the function or a part of the function, and then the question asks what is the scale factor or what is the initial amount, and see if they can identify that. And then you could take some of these story problems, give an extra credit assignment or maybe a quiz, and they get to answer their own problems for a quiz. And then finally, we have exponential variance. So what we are wanting to do here is we're wanting to create variance for a given exponential function. We're thinking of what are different ways that you can take a simple exponential function. So I've got an example here. Now, it's linked, it's the same link in both of these right here. So here's a simple one, right? F of x equals 300 times 2 to the x. Okay, so I could write, let me zoom this in here. There are 300 bacteria in a petri dish. The number of bacteria doubles every hour. Write a function to model the number of bacteria after X hours. Steve invests in a mutual fund. His initial investment is $300 and his value doubles every decade. Write a function to model the value of his investment after X decades. We're going to say the same thing here for the spread of an infectious disease. So I'm giving you the function. I need you to write 3 different problem situations. And I've got some example scenarios, the same ones from before. I found another one here for technology adoption. Same with exponential decay. I actually found an additional ones besides those initial 3 I gave you, the natural resource depletion, then also exponential decay of light or sound intensity. So that is what we're asking students to do, is write a word problem for that same exponential function, but using 3 different contexts, right? So that's the example. And then they swap, and then they solve. So obviously, if we were to swap this, I would hide this and give you these 3 and say, hey, all 3 have the exact same exponential function. But can you generate 3 different functions, 3 different verbal descriptions for that same function? What are some variations? They might need to be paired up. They might even need to be put into a small group for extra support, right? Obviously, you want to give them those contexts so they can think of different ways that you can use exponential growth and decay in real world situations. You might want to model how to write a story problem for the class and then ask them to write the other 2. So you give them that scaffold, right? After writing the scenarios, have students use different color highlighters or markers to note the following in the function. So that's what we have down here. So you notice I'm using this initial amount is yellow in each of these 3. My scale factor is green, doubles, doubles, doubles. And then my time unit is every hour, X hours, every decade, X decades, every hour, X hours. So you can use that. So you really lock in that they know the initial amount, they know the time unit, they know the scale factor. And those are all different things that you can do to teach Algebra 1 Standard A.9C.